This video will look at calculating the regression line for a negative relationship. So from example 2, where we had the number of hours of TV that a child watched and their GPA, we want to try to predict the grade point average for a child who watches 4.5 hours of television per day. So again, similar to same A and B formulas as we had seen in the positive relationship example. A equals sigma y, bottom of column 2, 24. Sigma x squared, bottom of column 4. Sigma x, bottom of column 1. Sigma xy, bottom of column 3. Denominator, n, we had 8 pairs of data. Sigma x squared with the square inside, bottom of column 4. Sigma x squared with the square outside, bottom of column 1 squared. Okay, do the multiplications in the numerator and the denominator. Do the subtractions. Then finally do the division. We get A equals 3.823. Okay, so we'll check that number out in a couple of minutes. Again, as I mentioned with B, the good news is we've already calculated both the numerator and the denominator. Denominator here matches A, so 151 comes across. The numerator matches the numerator from R, so the negative 43.2 that we had calculated earlier there. Do the division here, we get negative 0.286. All right, so we plug that into the correlation coefficient formula. Y prime equals 3.823 plus negative 0.286x, which is the same as saying y prime equals 3.823 minus 0.286x. All right, again, you want to sanity check this number a little bit. If we have a 0 for x, so we have a kid who watches no television at all, we would predict that they get a 3.8 GPA. Looking at our graph, that looks reasonable. This also shows you one of the weaknesses of this. We would never, in this model, predict a GPA above 3.8. Obviously, it's possible kids could do that. But with the data we have and the model we have, we would never predict a GPA above 3.8. Now, so that takes care of sanity checking the A value. In terms of the B, it looks like for every hour of television that the child watches, their GPA drops by 0.286, so almost 0.3. If you go back and start looking at that data, look at that line, for every 1 hour that you go to the right, you drop almost 0.3. Go over another one to the right, you drop another almost 0.3. And if you start looking through that, that again looks to be a reasonable number looking at your graph and your data. Now, we want to predict the grade point average for a child who watches 4.5 hours of television. We plug 4.5 in for our x. Take that times the 0.286, subtract from 3.823, we get 0.2536, which rounding down to a legitimate GPA is 2.5.